Hello everyone and welcome. Thank you for watching. We continue with KCSE Mathematics revision. This is New Dawn Series 2025. We shall solve all the questions in this paper, and I believe they're going to help us as we prepare for KCSE examinations. Let's go straight to the paper. This is section 1. Answer all the questions, 50 marks. Without using mathematical tables or calculator, evaluate, giving the answer in decimal form. The instructions are without using mathematical tables or calculators. So throughout your workings, you're supposed to ensure that you don't work out these questions using mathematical tables or calculator. Everything should be done manually. Therefore, we're going to simplify these workings by expressing the decimals in terms of fractions. Look at the numerator. 0.16 is equivalent to 16 divided by 100 multiplied by 0.2 is the same as 2 divided by 10. And then we're subtracting 0.004. 0.004 written in decimal form will be 4 divided by 1000. And then for the denominator, 0.07, that is 7 divided by 100. Once you've done that, this will simplify your workings. This is what you're going to do for the numerator. So for the numerator, and start with that, we have 16 over 100 times 2 divided by 10. So this will give 16 by 2, that will give that 2, divided by 100 times 10, that will give 1000. Then after we've done that, we subtract, so that 2 divided by 1000, subtract 4 divided by 1000. We subtract this, the LCM of 1000 and 1000, that is 1000. Then this will give 32, subtract 4, and that will give 28 divided by, so that is the numerator. Now we take the numerator, which is 28 divided by 1000. We divide by the denominator, which is 7 divided by 100. This will give 28 divided by 1000 multiplied by the reciprocal of 7 over 100 will be 100 divided by 7. And divide out 7 by 7, 1, 28 by 7, we have 4. So this will give 4 divided by, there's some zeros here, by 100, 1, by 100, we have 10. So we remain with 4 divided by 10. 4 divided by 10 written in decimal form will give 0.4. And that is a solution. Question 2. A family used 2/5 of its monthly income on school fees. 3/4 of the remaining amount was used on family upkeep, while the rest was invested. The family invested 13,500 shillings monthly. Calculate the amount of money the family used on school fees every month. So these are questions on fractions. Let's go to the solution. So 2/5 was used on school fees. So for the fees, that was 2/5. Then 3/4 of the remaining was used on family upkeep. So family upkeep was 3/4 of the remaining. So what is the remaining? So after using 2/5 on the fees, what remained, assuming that the whole amount was 5 over 5 or 1, that is how we get the remaining. So subtract 2/5. So the remaining is 3/5. So upkeep is 3/4 of the remaining, and the remaining is 3/5. So this gives, when you work it out, this will give 9 divided by 20, while the rest was invested. So what is the rest? Now the rest is how you're going to get the rest. Now the whole salary is 1 or 5 over 5. You can use any fraction or 20 over 20. Then we subtract. This is how we get the remaining. The fees was 2/5. And then the upkeep 9 over 20. Like that. This will give 1 subtract 2 over 5 plus 9 over 20. This will give 17 over 20. And when you work it out, this will give 3 divided by 20. Therefore, for the investment, it was 3 over 20. Now, the family invested 13,500. So this fraction that was invested was 3 over 20, and this represents what amount? 13,500. So the question, how much was used on school fees? School fees was 2/5. So what about 2/5? So we cross multiply. So this will give 2/5 times 13,500 times the reciprocal of 3 over 20. This will give 20 over 3. So this is what is going to give us the amount that was used in school fees. Use a calculator to work out that, and this will give 36,000. Question 3. Solve for x in the equation. Is a question on indices. 5 power 2x subtract 5 power 2x minus 1 is equals to 500. So look at the left hand side of the equation. So for the left hand side, it is possible to split 5 to power 2x minus 1. So we shall have 5 to power 2x subtract. So for 5 to power 2x subtract, that one you're going to write it as 5 to power 2x times 5 to power 1. We're simply splitting that. So 5 to power 2x subtract 1 is equivalent to 5 to power 2x multiplied by 5 to power negative 1. Everything is equals to 500. Now look at these two. You'll find something common here. So 5 to power 2x is common. So you factor out that 5 to power 2x is common. So when you factor out there, for 5 to power 2x, you remain with 1. Then subtract. You factor out whatever is in the bracket. When you factor out 5 to power 2x from whatever is in the bracket, you remain with 5 to power negative 1 is equals to 500. So this will give, and remember that 5 to power negative 1, it is important to note this. Note that 5 to power negative 1 is the same as 1 divided by 5. So we can substitute that. So we have 5 power 2x multiplied by whatever is in the bracket will now be 1. I'll do it here. 1 subtract 1 over 5. And this will give 4 divided by 5. Very important that. Note that. So whatever is the bracket, so whatever we have here will be 4/5. So we multiply by 4/5 is equals to 500. So from here, you can simply, remember you want to solve for x, so you can eliminate 4/5 by multiplying both sides by 5 over 4. That is a reciprocal. 5 over 4. And this side you can multiply it by 5 over 4. When you do that, on the left hand side, you will remain with 5 to power 2x is equals to, now what about this? 500 times 5 over 4, that will give 625. That will give 625. Use a calculator, you'll confirm that. So that is what you get. Remember what we've done here. We multiply both sides by the reciprocal of 4 over 5 in order to get rid of 4 over 5 from the left hand side, like that. So after doing that, now you notice that you have 5 to power 2x is equals to 625. It is possible to express this one to the same base. So you shall have 5 to power 2x is equals to 625 to the base of 4 in power form will be 5 raised to power 4. So from these, you can see the bases are the same. So you simply pick the powers, and that is what is going to give us the solution. So 2x is equals to 4, and here x will be equivalent to 2. Question 4. A lorry leaves Mombasa at 10 a.m. traveling at 48 kilometers per hour. At 11:15 a.m., a bus follows traveling at 80 kilometers per hour. How far from Mombasa does the bus catch up with the lorry? The question on time and speed. So the first thing we're going to do is to get the distance traveled by the lorry by the time the bus is beginning the journey. You can see the lorry leaves at 10 a.m. and then the bus follows 1 hour 15 minutes later, that is 11:15. So we need to get the distance traveled by the lorry at 11:15 a.m. and that would be the distance between them at 11:15 a.m. the distance between the lorry and the bus. So how do we get the distance? Get distance by speed times time. So the speed of the lorry is 48 kilometers per hour, and then the time that is from 10 a.m. to 11:15 a.m. that is a difference of 1 hour and 15 minutes. So this will be 48 kilometers per hour times 5/4 hours, and this will give 60 kilometers. So by the time the bus was beginning the journey at 11:15, the lorry had moved for 60 kilometers. So 60 kilometers is the distance between the lorry and the bus at 11:15 a.m. and this is the distance that the bus has to travel in order to catch up with the lorry. So how do we get the time to catch up? So time to catch up, we're going to calculate this one using the relative speed. Remember how we get time? So how do we get time? Get the distance over the speed. So the relative distance, that is the distance between them at 11:15 a.m. is 60 kilometers. And then the relative speed, remember these bodies are moving in the same direction. So one is moving at 48 kilometers per hour, the other one at 80 kilometers per hour. And therefore, to get the relative speed, we're going to subtract. So 80 subtract 30, these are 48 kilometers per hour. That is the relative speed. So this is the relative speed. So this will give 60 kilometers divided by 32 kilometers. That is 80 subtract 48, 32 kilometers per hour. So when you work out these, you shall get 60 divided by 32. You'll get 15 divided by 8. That is hours. That is the time. 15 divided by 8 hours. So that is the time taken by the bus to catch up. So now we want to get the distance. So what distance? At what distance? How far from Mombasa does the bus catch up with the lorry? So we take distance by, we take the speed. This will be given by speed times the time. So the speed of the bus, which is 80 kilometers per hour, times the time taken to catch up, which is 15 for 8 hours. When you multiply these, you'll get 150 kilometers as the solution. Question 5. Find the area of the triangle whose sides measure 14 centimeters, 11 centimeters, and 17 centimeters. Also determine the length of the altitude on the side which measures 17 centimeters, correct to 2 decimal places. So this is what you're going to do. To get the area, first of all, you can see this is a triangle. We can just sketch it here because we need the other part for altitude. We need to have a sketch that you can understand it. So we have this side 14 centimeters and this one is 11 centimeters and this one you have 17 centimeters. So first of all, if you have a triangle given 3 sides to get the area, the easiest way is to use the hero's formula. So area will be given by the hero's formula. That is the hero's formula, where S is the average of the sum of the 3 sides. So the 3 sides, you add them, 14 plus 11 plus 17 you divide by 2. So here you'll get S as 21. That is S. Now to get the area, area will be given by S, which is 21. 21 subtract 17. 21 subtract 11. 21 subtract 14. Like that. So this is side B, taking that as a side C. So this will give 21 times 4 times, this is 10 times 7, like that. And this will give, when you multiply using a calculator, you'll get the square root of 5,880. So once you get the square root of that to 2 decimal places, you get 76.68. 76.68 centimeters squared. So that is the first part. We solved the first part. Now the one that is remaining is determine the length of the altitude on the side which measures 17. Altitude is the height. The height. That is a perpendicular height. The perpendicular height. And this will be the height on the side that measures 17. So you're going to have perpendicular distance from the vertex up there to that side that measures 17 centimeters. So that is the height that you are required to get. So you need to get this height. So how do you get that height? Now to get that height, we can simply use the area that we have already obtained, and that will help us. Why? Because when getting the area of the triangle, we still can use another formula, a half multiplied by the base multiplied by the perpendicular height. And since we have the area, which is 76.68, we can simply take a half, multiply by the base. We use the base as a 17, and then we multiply by the height. You're looking for the height. So we make h the subject. So height will be given by 76.68 times 2 divided by 17. We are making h the subject, and this will give 9.02 centimeters. So that is how we get the height or the altitude. Question 6. The diagram below shows 3 points OA and B, in which OB is equals to AB. Given that the bearing of A from O is 0.30 degrees and the angle ABO is equals to 50 degrees, calculate the bearing of O from B. 3 marks. So that is a question. So you're supposed to calculate the bearing of O from B. So you shall draw the true north at B in order to get the bearing of O from B. So we start by drawing the north. So we construct the north. We'll construct the north at B. Use the red. So that is the north. We construct the north here at B. So the angle that we require to get is this particular angle here. This is the angle. We need to get the whole of that angle. Remember, for the true bearing, we measure from the north in a clockwise direction. From north in a clockwise direction. So that is the angle that we need to get. There's something you're given here. You can see these two signs here. Shows that this is an isosceles triangle. So these will be 65. The base angles of an isosceles triangle. And this one will be 65. So you can have the sum to be 180. So I'll also extend this line here. I'll have to extend this line. I'll extend it. So that there's an angle here I want you to observe. Looking at this line, it is parallel to this line that I've drawn here. And then this one is a transversal. So this angle, 30 and 65, that is 95, is equivalent to this that is here. Is equivalent to this angle that is here. So this angle here is, this angle is 30 plus 65. It is 95. So the whole of this angle is corresponding to this angle that is here. So that is 95. Looking at this is parallel, then this is a transversal. Then look at this. This is a straight line. This is a straight line. So 50, 95. That is 145. So the remaining angle here to make 180, the sum of angles on a straight line will be 35. So that now when you add This will be 85 plus 95. This will be 180. Now, once we get that, it is possible now to get this angle. Look at this angle. It is possible to get this angle that is here. It is possible now because we just need to take 360 and then you subtract this angle that is here. So to get this angle, the required angle, we'll take 360 angles at a point, then subtract 50 plus 35. So that is what you're going to do to get that angle. So we shall have 360 subtract 50 plus 35. And this will give 275. 275 degrees. So the whole of this angle here will be 275. That is true bearing. You can also give it in form of compass bearing. So in terms of compass bearing, this angle is now the compass bearing of O from B. B is to the northeast, and this angle here is 50 plus 35, 85. So O is to the north of B, then 50 plus 35, 85 degrees to the west. So you can give either of those two. Question 7. The table shows the mean of the weight of some turkeys and geese. So the table is there. Number of birds, the mean is given, turkeys and geese. Find the mean weight of 27 birds. So the 27 birds is 9 turkeys plus 18 geese. That is what gives 27 birds. So to get the mean of these 27 birds, and you're given the mean of 9 turkeys to be 7.1, to get the total weight in kg of 9 turkeys, we shall get 7.1 times 9. And then plus total weight for the geese will be 18 times their mean. That will give the total weight in kg. And then how to get the mean, we divide by the total number of birds. All these are 27. So that is what you're supposed to do. So this will give 63.9. That is 77.1 times 9 plus 18 times 5.2. That will give 93.6. And then you divide by 27. So once you use a calculator and work out these, you'll get 5.833 kg. Question 8. In the following figure, triangle ABC is a uniform cross-section of a solid ABCDEF. Given that BE is one of the edges of the solid, complete the sketch showing the hidden edges with broken lines. 3 marks. So I'll first complete what you're required to have. Remember, if to complete this, we're required to have, I'll sketch the whole diagram that you need to have to complete this. So this is what you're given. That is what you have. And now to complete, you need to ensure that you draw something like this. So that is what you need. You need to complete it so that it may look, this is a wedge. This is a wedge. So you need to have something like that. And you're supposed to ensure that all these measurements that you're going to use are equal. For example, we have BC should be equivalent to E. Let's say this one is D. Okay, and then we have A there. And you can complete these ABC, D, E, F. F is there. So you are supposed to be aware when you're completing that these measurements, they are equal, like AC is equals to FD, BC is equals to ED, BE is equals to AF. Those measurements are going to help you. So let me now go to the actual drawing, and you need a pair of compass to do this. So this is what you're supposed to do. First thing, you take this measurement BC. So I'll take the measurement BC. So take the measurement BC. Take the measurement BC. carefully using your pair of compass. So that is what I'm taking. So that is BC. So with that measurement BC, remember BC is equivalent to, so BC is equivalent to ED. So you stand at E with that measurement, you stand at E, and then with that radius, you mark an arc like that. So that will help us in order to actually get the measurement BC and ED to be uniform. Then from there, you want to take BE, go and take a measurement BE. BE should be equivalent to CD according to what I've completed there. So take that measurement. So that is a measurement BE using a pair of compass. Then stand at, you're transferring that measurement, stand at C. And now standing at C, you cut that arc. You cut that arc. So I'd like you to look at the point of intersection of these two arcs. That point of intersection, you're going to use a ruler and you join from C. So from C to that point of intersection, then from E, again you join that way. So you now have point D. Point D is there. So now you have point D. So this is a point D. Now the other measurements that you're going to take is AC. Look at AC. So AC is the next measurement. So take the measurement AC. Measurement AC. So that is the measurement AC. So taking that measurement is what you're going to do. Now standing at D, you simply mark an arc there at the top. Now you're transferring in order to have DF. Mark an arc there. And then from there, take this measurement again, BE. BE should be equivalent to AF. Look at the diagram that we completed. So now we want to get AF. So BE is equals to AF. So take the measurement BE and then stand at A in order to get this. So you actually cut that arc like that, and that point is going to give us that point F, the point of intersection there. So that is what you're supposed to have. So you join these to that point of intersection, and then you also join this one like that. Okay, and then you have broken lines. The broken lines are supposed to be indicated very well. So this ED is supposed to be broken. That is supposed to be broken. And then another one that is supposed to be broken is this is the line. Let me draw it and break it. So we have this other one here. So this one is supposed to be broken. This line is supposed to be also broken. So now you have shown all the hidden lines and you have completed the diagram accurately. So that is how you're supposed to do that. Question 9. A Kenyan businessman intended to buy goods worth $20,000 from South Africa. Calculate the value of the goods to the nearest South African rand, given that $1 is equivalent to 101.9378. 1 South African rand is equivalent to 7.6326 Kenya shillings, 3 marks. So we're supposed to convert first thing $20,000. We convert that on to Kenyan shillings. So that is what you're going to do. Then the Kenyan shillings, we convert them to South African rand. So $1 is equivalent to 101.9378. So what about $20,000? So that one you just need to multiply to convert. So it is 20,000 multiplied by 101.9378. 0.78. So this will give now the amount in Kenyan shilling. So when you multiply these, you will get 2,038,756 Kenyan shillings. Then after that, we shall convert the Kenyan shillings now to South African rand. So 1 South African rand is equivalent to 7.6326 Kenyan shillings. So what about these 2,038,756? So what about that? So to convert this one, we are going to divide. So we take 2,038,756. We divide by 7.6326. And this will give, supposed to give this one to the nearest South African rand. So once you work out your calculator, you'll get 267,112. That is the nearest South African rand. So this is South African rands. So that is how you're supposed to solve that. Question 10. The diagram shows a sector of a circle with center O. The radii OA and OB each have length 10 centimeters and the size of the reflex angle AOB is theta radians. The sector shaded in the diagram has a perimeter of 65 centimeters. So the diagram is there. You're supposed to find the area of the shaded sector. Find the area of the shaded sector. So what do you need to get the area of the shaded sector? Look at what you've been given. You're actually given the reflex angle AOB in theta radians, and then you have the perimeter of the shaded sector, which is 65 centimeters. So how do we get the area of the shaded sector? The area will be given by the angle at the center there, which is in theta radians, divided by 360, which is 2 pi radians, times radius. We have pi radians times radius squared. So that is how we get the area of that sector. Now this is the same as, remember how we get when you're given the angle in terms of theta, we get it as theta divided by 360 pi r squared. So the only difference is that the angle that we are given this time around, it is in theta radians. So that is why we're using 2 pi radians to work out these. So what we don't have is actually that angle in theta radians at the center. And what is going to help us to get that angle is the perimeter. So the perimeter of the shaded sector. So how do we get the perimeter? The perimeter is given as 65. So 65 is equals to, we get the perimeter from A, you can see the length of this arc, all the way to B. That perimeter, how do we get that perimeter? And then once we get that, we have to add 10 plus 10. So we start with this. How do we get the length of this arc? That one will be given by theta radian divided by 2 pi radians times 2 times pi radians times radius. That is how we get it. Remember how we get the length of the arc? The length of the arc, when you're given the angle as theta at the center, theta divided by 360 times 2 pi r. So we are only having it different because we have the angle in theta radians. That you have, instead of using 360, you're using 2 pi radians. So once we do that, we must add the 2 radii. That is from this point, A to O, that is 10 plus 10. So that will be 20. 10 plus 10, that will be 20. So that is what is going to give us 65. So therefore 65 is equals to, so these are pi radian and pi radian. We divide that and then by 2, 1 by 2, this is 1. So once we simplify these, we'll get pi radian times radians. This will give pi radians times r. The radius is 10 and then plus 20. So this will give 65 is equals to 10 theta radian plus 20. So making theta radian the subject of the formula, you get 10 theta radians is equals to 65 subtract 20, that will give 45. And then we divide both sides by 10 and you get theta radians to be 4.5. So once you get that, now we can get the area. The area will be given by theta radian. We already got that as a 4.5 from this formula, divided by 2 pi radians times pi radian times radius squared, which is 10 squared. So these will give, so these are radian and these radian disappear. And then we shall have these will be 10 squared, that will be 100. So you'll be left with 4.5 times 50. 0.5 times 50, and these will give 225 centimeters squared when you multiply these. Question 11. Given that 2, 0, 0, negative 3 multiplied by mn is equals to 10, 1, find the value of m and n. These are multiplication of matrices. The first one is this one is a matrix of order 2 by 2, and you're multiplying this one by a matrix of order 2 by 1. So the solution, we shall have a matrix of order 2 by 1. So let's multiply. You know how to multiply matrices, rows times columns. So 2 times m, that is a 2m. So these are 2 times m, that is 2m. Then plus we have 0 times n, that is 0. That is the first row. We go to the second row, 0 times m, that is 0. Then plus negative 3 times n, that will be negative 3 n. So that is what you get. Everything is equivalent to 10, 1. So 2m, the first row plus 0, that will get 2m. And then we have 0, subtract negative 3n. This one will give negative 3n. And this one is equals to 10, 1. Like that. Now you just equate the corresponding elements. You can see these are 2 by 1, 2 by 1 matrix. Both of them are 2 by 1 matrix. So 2m corresponds to 10. So 2m is equals to 10. And here you get m is equivalent to 5. And then negative 3n is equals to 1. So n is equals to negative a third. Question 12. Simplify the expression. So I have that expression there. So look at the numerator and the denominator. We start with the numerator. So for the numerator, you have x squared subtract 7x plus 12. You can use factorization to factorize these. So looking for two numbers, whose product is 12. And then the sum is negative 7. Those numbers are negative 4 and negative 3. So we shall have x squared subtract 3x subtract 4x plus 12. So factor out, you have x. This is x subtract 3. Then negative 4 is common. X subtract 3. So for that one, we shall have x subtract 4 multiplied by x subtract 3. That is the numerator factorized. Now let's go to the denominator. For the denominator, we have 4x subtract x squared. When you look at 4x and x squared, x is common. So factorize x, you shall have 4 subtract x, like that. Now look at the numerator, both the numerator and the denominator. So that is the denominator, that is the numerator. Now you're supposed to divide. So for the solution, you shall have x subtract 4, x subtract 3, and then divided by the denominator x, 4 subtract x. Now when you look at what we have in the numerator and the denominator, nothing can divide out, but we can modify the denominator and write it like this. So the numerator remains like that. But for the denominator, we can factor out negative x. And when we factor out negative x, we shall have x subtract 4. You see the same thing, because you have negative x times x, that is negative x squared, which is there. And then negative x multiplied by negative 4, that will be positive 4x. So it is still the same thing. So what we have here, is still the same thing. With that, when you open the bracket, you realize the same thing. Now, when you look at now the numerator and the denominator, you find that x minus 4 is common in the numerator and the denominator. So you can divide that one out like that, and you remain with x subtract 3. And this one, you can put the negative there. So you have negative and then x. So you have negative x. Or there's also another way you can write this one. So for this one, you can also leave the answer as 3 subtract x divided by x. So these two answers are the same. So you can leave the negative outside there, or you can multiply the negative, whatever is in the brackets, and you have those two. So those are the two possible solutions for that question. Question 13. ABCD is a quadrilateral with AB is equals to 4 centimeters and DC is equals to 9 centimeters. Angle DAB is equals to 90 degrees. Angle ABD is equals to 60 degrees. And angle BDC is equals to 40 degrees. Calculate BC correct to 2 decimal places. The diagram is not drawn to scale. So just study that diagram, ABCD, and then look at the question. You're required to get BC. So for that triangle BCD, we have 40 degrees and we have 9. So the best approach is first to get DB. Once we get DB, in that triangle DBC, we shall have DB and DC. Those are two sides. And then we will have an included angle that is 40 degrees. And that will help us to use a cosine rule to do that, to get BC. Now, how do we get DB? We are going to use triangle ABD. That is a right angle triangle. And we're going to use trig ratios. And we have an angle 60 degrees and we have one side. So it is possible to use trigonometric ratios to get DB. So therefore DB, for DB we shall use trig ratios. I'll use cosine. So cosine of 60 degrees. I'm looking at triangle ABD. That is what I'm using. Cosine of 60 is equals to adjacent side, which is AB, divided by DB. So this will help us to get DB. So cosine of 60 degrees is equals to AB is 4 centimeters divided by DB. So DB therefore will be given by, DB will be 4 divided by cosine of 60. And this will give, using a calculator to work out this will give 8 centimeters. So this one is 8 centimeters. Now after getting DB, now considering triangle DBC, having two sides and an included angle, we can use the cosine rule. We can use the cosine rule to get BC. So cosine rule, so BC squared is equals to DB squared plus DC squared minus 2 multiplied by DB multiplied by DC cosine of angle D. So that is the cosine rule. Now we can proceed. So BC squared is equals to DB, that is 8 squared, plus DC, that is 9 squared, minus 2 times 8 times 9 cosine multiplied by cosine of 40 degrees. So this will give 8 squared plus 9 squared, that will give 81 plus 64. This is a 64 plus 81 minus, so this will give 2 times 8 times 9, that will give negative 144 cosine of 40, like that. And everything here, when you simplify using calculator, you get BC squared is equals to 64 plus 81 subtract 144 cosine of 40. That will give 34.696. And now this is B squared. In order to get BC, get the square root both sides. The square root of BC squared will get BC, then get the square root of 34.696, and that will give, correct to 2 decimal places, you get 5.89 centimeters. So that is how you're supposed to work it out. Question 14. The image of P, negative 2, 5, under a translation T is P prime 2, 2. Q prime, which is 9, negative 5, is the image of Q under the same translation T. Determine the coordinates of Q. This is a question on translation, and there's something which is very important. For translation, if you're given the object, to get the image under translation, we add the translation vector. So when you get the object, add the translation vector. That is when you get the image. So that is how you work out the translation. Now, in this case, we don't have that translation, so we can let the translation vector to be given by AB. So now we have the image of P is given, and we have, if we take P, which is negative 2, 5, we write it in column form. That is the object. Then we add the translation vector T, AB, that should give P. So this is a P. This will give us the image of P, which is 2, 2. Like that. So now we can add the left hand side, negative 2 plus A, of negative 2 plus A, and then 5 plus B down there, like that, is equals to 2, 2, like that. So you just need to equate these corresponding elements. So negative 2 plus A is equals to 2. So negative 2 plus A is equals to 2. So A will be 2 plus 2, that will be 4. Then 5 plus B is equals to 2. So B is equals to negative 3. So therefore the translation vector AB, A is 4, B is negative 3. So that is the translation vector. Now, Q prime is the image of Q under the same translation. Now determine the coordinates of Q. So since we don't have the coordinates of Q, we can let the coordinates of Q be given by XY. xy. And that is the object. So q, which is xy, when we add that translation vector, which is 4, -3, we are going to get the image of q, which we have here as 9, -5. You take the object, add the translation vector to get the image. That is how we carry out questions on translation. So we add the corresponding elements in the first row, that is x plus 4 is equals to 9. So here x is equals to 5. The second row, y plus -3, that will be y subtract 3 is equals to -5. And therefore y is equals to -5 plus 3, that will give -2. And therefore the coordinates of q will be given by here. Q therefore will be given by the coordinate x is 5 and y is -2. So those are the coordinates. Question 15. Point -1, 5 lies on the curve y is equals to ax squared plus bx, and the gradient of the tangent to the curve at x is equals to 2 is 5. Calculate the values of a and b. So we start with whatever we're given here. The gradient of the tangent to the curve at x is equals to 2 is 5. So how do we get that gradient first? We'll get the gradient from the function of the curve. So the function of the curve is y is equals to ax squared plus bx. So to get the gradient of the tangent to the curve at x is equals to 2, we must get the gradient function first. This is what will help us to get the gradient at this point, x is equals to 2. So the gradient function, you differentiate this function with respect to x. So you shall have differentiate ax squared, you shall have 2ax. Then differentiate bx, you get b with respect to x. So the gradient of the tangent will be given by this function. This is a gradient function. And now at x is equals to 2. At x is equals to 2. You're given that the gradient is 5. So we need to substitute x is equals to 2 in this gradient function. We shall have 2 times a times x, and x is 2. So that will give us 4ax plus b. Not 4ax, sorry. We shall have 4a. You are substituting 2 in that function. So this will be 4a plus b. And the gradient is given as 5. So that one should be equivalent to 5. So that is the first equation that we get. Let's see if we can manage to get another equation. Because you have two unknowns, so you must have a simultaneous equation. Solve these. So the other equation will come at this point. So point -1, 5 lies on the curve, and the gradient of the tangent to that point is 5. So looking at that function, since we have the x, we have x and y, so you're going to use the function y is equals to ax squared plus bx, and then we use this point -1, 5. We substitute x and y. X is -1, y is 5. So substitute that in this function. So y is 5. Then x is -1. So this will be a. This will be -1 squared plus b -1. So this will give 5 is equals to, we have a minus b. So this is going to give the second equation. So now we have two equations. The first one is 4a plus b is equals to 5, and the other one is a minus b. You can reorganize this. This is a minus b is equals to 5. So you can use any suitable method. I'll use elimination. And I'll start by eliminating b. So to eliminate b, we have b and negative b. I'll add the 2. So 4a plus a, you get 5a. Negative b plus minus b, that will be 0. It is eliminated. And then 5 plus 5, you have 10. So a is equals to 2. So if a is equals to 2, substitute here. So a minus b. So you have a, which is 2, minus b is equals to 5. So b is equals to negative 3. b is equals to negative 3. So we have the values of a. So a is 2 and b is negative 3. Question 16. Use the Cartesian plane provided to solve graphically the simultaneous equations 2x plus 3y is equals to 12 and 5x plus 4y is equals to 10. 3 marks. So you're supposed to solve these simultaneous equations graphically. So how do you do this? You simply have to draw this straight line given by this equation 2x plus 3y is equals to 12. You draw that line by having at least 2 points. Then you draw the other line 5x plus 4y is equals to 10 using at least 2 points. Once you've drawn those 2 lines, the point of intersection of the 2 lines give the solution, because the point will be given by the x and the y coordinate. So that is why you're going to get the solution, what is x and what is y. So we draw the first line, 2x. So 2x plus 3y is equals to 12. You just need at least 2 points to draw that line. So the first one, when x is 0, when you have x is 0, you have to choose suitable points for these. Y will be 4. Then when y is 0, you shall have x is 6. Those 2 points are enough. You can use that one for confirmation, but the 2 are okay. So we draw that line first. So 0, 4. 0, 4 is this point. And then 6, 0 is this point. So let me mark them. So 0, 4 is this point here. And then we have 6, 0 is that point. So draw a straight line. Draw a straight line. You draw a straight line like that. So that is the line. It is passing through these 2 points, 0, 4 and 6, 0. So that is the first line. So the other one is, so you can write the equation of these. So this is x, 2x plus 3y is equals to 12. And then you have the other one, 5x plus 4y is equals to 10. So we have at least 2 points for these again. So when x is 0, y will be 2.5. And then when y is 0, x will be 2. And still you can use another point. Can add another one. I'm adding because I don't like using the decimals so much. So let me see. If you have x as -2, you'll have y as 5. That is another possible point. So let me use any 2 points here. So 2, 0, 2, 0, 2, 0 is here. So 2, 0 is there. And then you have -2, 5. So -2, 5, -2, 5 is here. -2, 5 is here. So this is the point here. So me draw a line passing through those 2 points. Use a ruler to do this. And there we have that line. It is passing through those 2 points, 2, 0, and we have -2, 5. So look at the point of intersection. This is what is going to give us a solution. So the point of intersection is here. So let me identify this a point of intersection. So this is the point. So that is the point. And when I look at this, I give the x coordinate. So I'll draw a line from that to get that point. So here we have So that is the point. So I'm drawing a straight line, and then from these we have that point. So let me read these points. So given by this is the x coordinate, that will be negative 2.5. Is giving is negative 2.5, and then for y, this is you should know the scale that you're using. The size of one small square is 1 divided by 5, 0.2. So these will be 5.2.4.6, around 0.6 there, around 0.6. So x, point of its x is negative 2.5, which is here. So negative 2.5, and then y is here. So 5.2.4.6, 5.6, and therefore we've given the solution, because it's supposed to solve the simultaneous equation graphically. So x coordinate of the point of intersection is negative 2.5. The y coordinate of the point of intersection is 5.6. Section 2, question 17. 3 business partners, Anthony, Beatrice, and Charles, contributed shares of 120,000, 180,000, and 240,000 respectively to boost their business. They agreed to put 20% of the profit accumulated back into the business and use 35% of the profits for running the business, that is official operations. The remainder was to be shared among the 3 partners in the ratio of their contribution. At the end of the year, a gross profit of 225,000 was realized. Part A, calculate the amount 1 put back into business. The amount put back into business. Now, when you read this statement again, you'll notice that the amount put back to business is supposed to be 20%. It is supposed to be 20%, as you can see here. 20% of the profit accumulated. And what is the profit accumulated for that year? It is 225,000. So the amount put back to business will therefore be 20%, which is 20 over 100, times the profit, that is 225,000. And this one will give, when you work out this will give 45,000. So that is the amount put back to business. Then part 2, the amount used for official operation. The spelling mistake here. Used for official operations. So it is here. That part is the amount for official operations is 35% of the total profit. So this will be 35 over 100 times the total profit, which is 225,000. So this gives 78,750 shillings. We go to the other part, calculate, that is part B, calculate the amount of profit each partner got. The amount of profit each partner got. Now let's go to the statement there. After putting 20% of the profit back into the business and 35%, the remainder was to be shared among the business partners. So we need to now get that remainder. After putting 20% back to business, then 35% for official operations, what remained? So the total profit is 225,000. Now we are getting the remainder. So we get this by 225,000. That is the total profit. And then we subtract the amount put back to business, which is 45,000, and the amount used for official operations, which is 78,750. That is what you're supposed to do. And this will give the remainder, and this is the one that was shared. So this will give 101,250. So this is the amount to be shared, and is supposed to be shared in the ratio of their contribution. So we need to get the ratio of the contribution from the first statement here. They contributed Anthony 120,000, then Beatrice 108,000, and Charles 240,000. So we need to get the ratio from there. So we need to get the ratio. So the ratio of the contribution. So the ratio of the contribution, that is Anthony ratio Beatrice ratio Charles. This is 120,000 and 180,000, and this is a 240,000. So when you simplify this fraction, you'll get 12 ratio 18 ratio 24. When you divide everything by 10,000, that is, when you divide everything by 10,000, that is what you get. Then you divide again by 6, you'll get 3. This will give 3. Divide everything by 6, this will be 3. This will be 6 ratio 4. So you're dividing everything by 6. So everything by 6, this will give, to divide this one properly, So when you divide everything by 6 by 12, this will give 2, this will give 3, and then this one will give 4. That is when you divide the ratio 12, 18, and 24 divided by 6. Now that is the ratio simplified. Now after getting that, now we can use that to get the ratio of the contribution of each one of them. And this is how we're supposed to do it. So for Anthony, the ratio is 2. So this will be 2 divided by the total ratio, which is a 2 plus 3 plus 4. That will give 9. So it is 2 divided by 9 times the amount shared is here, 101,250. So this gives 22,500. That is for Anthony. Then for Beatrice, 3 divided by the total times the profit, which is 101,250. This gives, you work out this will give 33,750. 33,750. And then we have Charles. The ratio for Charles is 4 divided by 9 times 101,250. These will give 45,000. Give 45,000. And you've answered the question, the amount of profit each partner got. We go to the last part. So for the last part, if the amount put back into the business was added to individuals' shares proportionately to their initial contribution, find the amount of Charles' new shares. If the amount put back to business was added to individuals' shares. So we need to get that amount that was put back to business was 45,000. We got that. So it is here. The amount put back to business was from the first part. We got that one as 45,000. So if this amount, according to the question, was added to individuals' shares proportionately, so that amount was added to each of the 3 members according to the ratio of their contribution. That is what we mean by proportionately to their initial contribution. So the amount put back to business, said is 45,000. So from this amount, we need to know the ratio for Charles was 4 divided by 9. That was the ratio of the contribution. So we want to get the amount that is going to get. So 4 divided by 9 multiplied by this amount that is being shared. Amount put back to business is 45,000. So we want to get the shares Charles got from these 45,000. And this will give 20,000. So that was the amount Charles received from these 45,000. Now the question is, find the amount of Charles' new shares. So remember the initial shares the initial shares of each one of them that they contributed was 120,000, 180,000, and Charles had shares of 240,000. So 240,000, those were the initial shares. So 240,000. And then there are these new shares that have been added. That is 20,000. Now look at the new shares, 20. So you add 20,000. These will give the new shares now. And these will give 260,000. So that is the amount of Charles' new shares. And that is how you're supposed to solve that question. Question 18. A solid is formed by placing a cone on top of a hemisphere. The cone and the hemisphere each have radius r centimeters. The height of the solid is 10 centimeters. The curved surface area of the hemisphere is 145 centimeters squared. Part A. Calculate the value of the radius r correct to 2 decimal places. 2 marks. So the first part, you're supposed to calculate the value of the radius. So what is going to help us? Now from this part, you have 10 centimeters at the height. Then you have this curved surface area of the hemisphere. This is what is going to help us. The curved surface area of the hemisphere. So how do you get the curved surface area? Is given by the formula for getting the curved surface area of the hemisphere is 2 pi r squared. 2 pi r squared. Therefore, the curved surface area, which is 145, is equivalent to 2 multiplied by 22/7 times r squared. So that is how you get the curved surface area. And when you work out these, you notice that you get the value of r. So you simply make r the subject. So making r the subject, you'll have 145 multiplied by 7, everything divided by 2, multiplied by 22, you get the square root of that. This is what is going to give you the value of r. Use a calculator to work out this, and this one should give you, you're supposed to give the answer correct to 2 decimal places. So this will give 4.80 centimeters. So that is the radius. So therefore, in the diagram here, you should also notice that this one is also radius, and this is 4.8, and this one is 4.8, and also this side again, this is radius, this is 4.8 centimeters. Part B, B1, calculate the volume of the solid. Calculate the volume of the solid. So this solid is made up of a cone and a hemisphere, and therefore, to get the volume of that solid, it will be given by the volume of the cone plus the volume of the hemisphere. So we start with the cone, the volume of the cone. How do we get the volume of a cone? The volume is given by a third pi r squared height. So this will be a third times pi, which is 22/7, times the radius of the cone. The radius of the cone is 4.8. We just got that. So this will be 4.8 squared, and then times the height, Now, do we have the height of the cone? No. So we need to get that. So the height of the cone, this is the height. So the height of the cone is here. But that one is very easy to get. Since we have the whole distance, the whole of this distance is 10. And we have the whole of this distance is 4.8. So height will be given by, 10 subtract 4.8 centimeters. 10 subtract 4.8. Because you take the whole of that height of the whole solid, and then you subtract the radius. So 10 subtract 4.8, that will give 5.2. So this will be 5.2 centimeters. So that one is 5.2. So now we have multiply by 5.2, like that. So you work out this and get the volume of the cone. So using a calculator, so you have 22 multiplied by 4.8 squared times 5.2, and then you divide by, this is 21. So this one gives a 125.51 centimeters squared, correct 2 decimal places. Now we go to the other part, which is the volume of the hemisphere. So how do we get the volume of hemisphere. How do you get the volume of the hemisphere? Volume is given by 2/3 pi r cubed. So that is how we get the volume of the hemisphere. So and this will be 2/3 multiplied by 22/7 times the radius, which is 4.8 cubed, like that. 2/3 times pi. So we multiply these. So this will be 44 multiplied by 4.8 cubed, like that. And then you divide by 21. You get 231.72. 231.72 centimeters. And this is not squared, but this is cubed. This is cubed. For the cone, again, that was 125.51 centimeters cubed. So now you have the volume of the cone and the volume of the hemisphere. So total volume will be 125.51 centimeters cubed plus 231.72 centimeters cubed. So you add these. So you add plus 125.51. So you have 125.51 plus 231.72. That gives 357.23 centimeters cubed. That is the volume of the solid. We go to the next part. Part 2. The cone is made of wood and 1 centimeter cubed of the wood has a mass of 0.8 grams. Calculate the mass of the cone. So this one is straightforward. So you have 1 centimeter cubed of the wood has a mass of 0.8 grams. So calculate the mass of the cone. The mass of the cone. So what is the volume of the cone? The volume of the cone is 125.51 centimeters cubed. What about that? So you simply multiply. You simply multiply these. So 125.51, 125.51 multiply by 0.8, and this will give 100.41 grams. 100.41 grams. The other part C, calculate the curved surface area of the cone. The curved surface area of the cone. The curved surface area of the cone. So how do we get the curved surface area? The curved surface area of the cone is given by pi r L, where L is the slant height. So we go to the diagram. And we need to get the slant height. So what is the slant height? So looking at this particular diagram here, the slant height is here, and we have this height. We got this one as 5.2, and then this one is 90 degrees. So we are going to use this triangle here. This is a right angle triangle to get the slant height. And for this one, we use a Pythagoras theorem. So slant height is given by, so we just use a Pythagoras theorem. So slant height is given by the square root of, looking at this, so 5.2 squared plus 4.8 squared. So 5.2 squared plus 4.8 squared. So that will give the slant height. So the square root of 4.8 squared plus 5.2 squared. And that gives 7.08 centimeters. So that is what you get. Now after getting the slant height, now we can use the formula. So surface area is given by pi, which is 22/7, times the radius. We got the radius as 4.8 times the slant height, which is 7.08. As simple as that. And this gives, when you work out this one using a calculator, 22 multiplied by 4.8 multiplied by 7.08, like that. And then you divide everything by 7. So you get 106.81 centimeters squared. And that is how you're supposed to solve that question. Question 19. Solution to this question by accurate drawing will not be accepted. The diagram, which is not drawn to scale, shows a triangle ABC in which the point A is 9, and point B is 1, -3. The point C lies on the perpendicular bisector of AB, and the equation of line BC is y is equals to 8x subtract 11. Question 1, part 1, find the midpoint of the line AB. The midpoint of the line AB. So you can see point A and point B. So how do we get the midpoint? So to get the midpoint, actually, let me indicate both points. Point A is 9, 9, and B is 1, -3. So this is how we get the midpoint. So this is x1, this is y1, this is x2, this is y2. So the midpoint is given by this formula, x1 plus x2 divided by 2, then y1 plus y2 divided by 2. So that is how we get the midpoint. So x1 in this case, so the midpoint, x1 is 9 plus x2, which is 1, you divide that by 2. Then y1, which is 9, plus y2, which is -3, divide that by 2. So this will give 10 divided by 2, this will be 5. Then this is a 6 divided by 2, this will be 3. So the midpoint is 5, 3. We go to part B. The equation of the perpendicular bisector of AB. The equation of the perpendicular bisector of AB. So the perpendicular bisector of AB, and there is a statement you're given here that point C lies on the perpendicular bisector of AB. So that means if we draw a line like that, we draw a line. So this one will meet that line from C, will meet that line AB at 90 degrees. So perpendicular bisector of AB is that line that is going to divide AB into 2 equal parts, and it will meet that line at 90 degrees. And remember that this point, we got that point as 5, 3. So that is, so for us to get the equation of that line, we need a point which we have 5, 3, and we need the gradient. We need the gradient. So we need to get the gradient. So the gradient of that line, AB will help us to get the gradient of that perpendicular bisector. So we start by getting the gradient of line AB. So gradient of line AB. So gradient of AB. So AB, we have points A and B. Previously they are there. So gradient is changing y, which is 9 subtract -3 divided by change in x, 9 subtract 1. So this gives 12 divided by 8. 12 divided by 8, which simplifies to 3 divided by 2. So that is the gradient of line AB. Now line AB is perpendicular to the other line that we've drawn there, passing through 5, 3. So therefore, the line of that perpendicular bisector, the gradient of that perpendicular bisector will therefore be -2/3. Why? Because if you have two lines that are perpendicular, assuming that this is M1, so M1 is the gradient of line AB, then M2 is the gradient of that perpendicular bisector of AB. When you multiply that, we should get -1. And since we have M1 as 3/2, we multiply that by M2, that will give -1. So M2, the gradient of bisector of AB, will be -2/3. Now the equation of that perpendicular bisector, we have a point where it passes, that is 5, 3. So we have 5, 3, and we have the gradient as -2/3. So to get the equation, you simply introduce another general point on that line, xy, and then you get the gradient. The gradient which is obtained by y subtract 3 divided by this change in x subtract 5 should be -2/3. So cross multiply, 3 multiply by, so this will be 3 multiplied by y minus 3 is equals to -2 multiplied by x minus 5, which will give 3y subtract 9 is equals to -2x plus 10. So this one gives, so 3y is equals to -2x plus 19, and this will give y is equals to -2/3. You divide everything by 3x plus 19 divided by 3. So that will be the equation of the perpendicular bisector of AB. We go to the other part 3, the coordinates of C. The coordinates of C. The coordinates of C. So we need to get the coordinates of this point. So how do we get that? Very easy. Now we are given the equation. We are given the equation of BC. The equation of BC is y is equals to 8x subtract 11. And then we have the equation of this perpendicular bisector. So we have already obtained the equation of this line, and we have the equation of this line. To get the point of intersection, we simply need to solve those two equations simultaneously, because you can see the two lines are meeting. So BC, we have the equation there, and this perpendicular bisector, they are meeting at this point. So to get the point of intersection, you remember how we solve the simultaneous equations graphically. We simply draw the two lines and then we get the point of intersection. That is where we get the solution, because the point of intersection has the x coordinate that gives the x value and the y. So once we solve the two equations of these lines simultaneously, we'll get x and y, and x and y will give us this point C. So now let's go straight. So we have this equation. So we have that equation. So we have this equation of this line, which is y is equals to 8x subtract 11. That is equation 1. And then we have the ones that we've already obtained here. Y is equals to -2, that's x, plus 19 divided by 3. So once we solve these two simultaneously, we'll be able to get the solution. All you need to do is simply reorganizing them. And for example, this one, I'll reorganize this one by first multiplying all through by 3. We'll get 3y is equals to -2x plus 19. And then I can continue taking 2x, -2x to the left hand side, have 3y plus 2x is equals to 19. Then for this one, we'll have y -8x is equals to -11. And see, now I have reorganized. So now solving them simultaneously, I will eliminate y. So I'll multiply equation 2 by 3. And this is what I will have. So I will have 3y plus 2x is equals to 19. That's equation 1. Then equation 2, you multiply all through by 3. You get 3y. Subtract 24x is equals to -33. Like that. Then you can subtract to eliminate y. So 2x subtract -24x, that will give 26x. And then this one is equals to 19 subtract -33, that will give 52. So x will therefore be 2. Getting x is 2, substitute. So y is equals to 8x subtract 11. 8x, 8 times 2, that will give 16, subtract 11. So y will give 5. So now you can see we have, after solving the two equations of the lines simultaneously, we have the point of intersection, which is x is equals to 2 and x is equals to 5. So that will give point C. The x is 2, x value is 2, then y is 5. So that is how we get the coordinates of point C. We go to the other part B. The point D is such that ACBD is a rhombus. Find the coordinates of D. Find the coordinates of D. So assuming that D is somewhere, when you look at this, if you complete it, D will be located. If this one is a rhombus, assuming that this is just an assumption, it's just an assumption that D will be located somewhere here. D will be located because this is a rhombus. So that this one is a rhombus to be a rhombus. So a point D will be there. Then there is something that is going to help us to get the coordinates of D. So you can let the coordinates of D to be x1, y1, like that. And then we have the coordinates of C. We've just obtained the coordinates of C as coordinates of C is 2, 5. The coordinates of C is 2, 5, like that. So, and then we have the midpoint. So you can see D is here, we assume D is here. Because the rhombus, this perpendicular bisector had to pass through D. This perpendicular bisector from C had to pass through D. And if this is the case, if this is C and this is D, then this is automatically the midpoint. This will be the midpoint of this line. It will be the midpoint. So we have point C, which is 2, 5. And we have 5, 3. So we have D here. So we can get that. Because having this one as a midpoint, we can get that. So this is how we get it. So C, I'll draw that line here. I'll draw the line here. So we have point C, which is 2, 5. Then you have the midpoint as midpoint is 5, 3. And then we have D. D is what you're looking for. So you let that one to be X1, Y1. X1, Y1. Now you know how we get the midpoint. So the midpoint, which is 5, 3, is obtained by getting 2 plus x1, 2 plus x1. So 2 plus x1 divide by 2, like that. And then 5 plus y1 divided by 2. 5 plus y1 divided by 2, like that. So that is how we get the midpoint. So 5, 3. 5 is equivalent to, if we just equate the corresponding value, so 5 is equivalent to 2 plus x divided by 2. 2 plus x1 divided by 2. So multiplying both sides by 2, you get 10 is equals to 2 plus x1. And therefore, x1 will be given by 8. Then this one corresponds, 3 corresponds to this. So 3 corresponds to 5 plus y1 divided by 2. So multiplying both sides by 2, you get 6. This one will give 6 is equals to 5 plus y1. And if this is the case, then y1 will be given by 1, like that. Now we have x1, y1. So therefore D will be x1, which is 8, y1, which is 1. So those are the coordinates of D. And that is how you're supposed to solve that question. Question 20, part A. An aeroplane traveled a distance of 660 kilometers at an average speed of x kilometers per hour. Write down an expression for the number of hours taken. So number of hours, you require to get time. That is time. Time is given by distance divided by the speed. In this case, the distance is 660 kilometers divided by the speed, which is x. That expression will give the number of hours. That is what you are required to give. Part B. On the return journey, the pilot took a different route. The average speed was 50 kilometers slower, and the distance traveled was 60 kilometers shorter than the outward journey. Write down an expression for the number of hours taken for the return journey. So on the return journey, you're given the average speed was 50 kilometers per hour slower, and the distance was also 60 kilometers shorter than the outward journey. So to give the number of hours for the return journey, still that one is time. So distance will have reduced by 60. So the outward journey, the distance was 660 kilometers. So we subtract 50 kilometers. We subtract a 60. This is 60 because it was 60 kilometers shorter. So that will be the distance. Then we divide this one by the speed. The speed again was 50 kilometers per hour slower than the outward journey. So for the outward journey, it was x kilometers per hour. So we subtract 50 kilometers per hour. So therefore, this expression, you write it as 660, subtract 60 to give us 600 divided by x, subtract 50. That will be the expression for the number of hours for the return journey. Part C, given that the outward journey took 12 minutes less than the return journey, form an equation in x and solve it. Form an equation in x and solve it. So given the outward journey took 12 minutes less than the return journey, form an equation in x and solve it. So that means if the outward journey took 12 minutes less, the first thing we're supposed to do, because the expressions that we have given are in terms of number of hours taken, we have to convert our first 12 minutes to hours. 12 minutes to hours. And that will be 12 divided by 60, which is a fifth of an hour. That will be a fifth of an hour. So the outward journey, how do we write this expression? We have the number of hours taken for the outward journey and the return journey. So if the outward journey took 12 minutes less, that means the return journey took longer. So if I take the number of hours for the return journey, which is 600 divided by x, subtract 50, I subtract the number of hours taken for the outward journey, which is 660 divided by x. That should give me that difference of 12 minutes, which is a fifth of an hour, or 12 minutes. So that is the equation you're supposed to form. Now you have to solve for x. You have to solve for x. And this is how you're going to solve for x. Now you get the LCM. You get the LCM of x minus 50, x, and 5. Get that LCM. And the LCM will be, the LCM of that will be 5x, x subtract 50. So having that as the LCM, you now need to multiply. You need now to multiply each term by that LCM. You multiply each term by that LCM. So this is how I'm going to do it. So I'll take 600. So 600 divided by x subtract 50. You multiply that by 5x, x minus 50, like that. Subtract 660 divided by x. Multiply this one by 5x, x minus 50 is equals to a fifth. You have to multiply that one as well. 5x, x minus 50, like that. So after doing that, x minus 50 will divide out there. And then x here will divide out here. And then 5 will divide out there. So you'll be left with 600 times 5x. That will give 3000x. Then subtract. Here you'll remain with 5 into brackets x minus 50. That will give, that will give 6. So you have to multiply 660. And then here you'll be having 5x. When you multiply this, 5x, subtract 5 times 50, 250, like that, is equals to, here you will have x is remaining, x subtract 50, like that. So from here, you can simplify. This will be 3000x subtract. So you multiply these. So you multiply. This is 660 multiply by 5, multiply, these are 300, then plus 660 multiply by 250, and that will be positive 165,000 is equals, this will be x squared, subtract 50x, like that. So from there, 3000 minus 300, that will be negative 300x plus 165,000 is equals to x squared minus 50x. Now reorganize this one to form a quadratic equation, and this is how you're going to do it. X squared, you just reorganize and collect the like terms together. X squared, you'll have x squared, so 300, so this one will be 300x minus 50x plus 300x. This will be positive 250x. This will be plus 250x. And then minus 165,000 is equals to 0. So this is actually the quadratic equation that you'll have to solve. Now to solve that, you simply need to use any suitable means. I'll use the quadratic formula. Use the quadratic formula to solve that. So Remember the quadratic formula. So where in this case I will have A as 1, B as 250, and C as negative 165,000. You can use factorization as well. So the quadratic formula is here. So x is equals to minus b plus or minus b squared minus 4ac divided by 2a. So x is equals to, so minus b is minus 250, then plus or minus b squared is 250 squared minus 4, a is 1, c is negative 165,000, like that. Everything divided by 2 times 1, 2. So that is what you're supposed to work out. So these will give negative 250 plus or minus whatever is in the bracket there, the square root of 250 squared minus 4. Well, these will be positive. It will actually be positive. 4 times 165. When you open the bracket, they will be positive 165,000. So you get 850 after getting everything, the square root of that, then divided by 2. So the first value of x will be negative 250, plus 850 divided by 2. So negative 250 plus 850 divided by 2. This will give 300. Now the other one, if we take negative 250 subtract 850, that will give us negative. And since x is speed, we only consider the positive speed. We ignore the negative speed. So for that one, having two answers, you're going to ignore one because we have two. The other one will be negative. When you work out the other one, it will be negative 550. So we are going to ignore this one because the speed here required is positive. So therefore, x is equals to 300. So that is the solution. So we have formed the equation in x, and we have solved that equation to get 300. Then the last part is find the time taken for the outward journey. So outward journey is the expression for the outward journey. Remember, it was 660. It was actually here, the outward journey. 660 divided by x. 660 part 1, 660 divided by x. So 660 kilometers divided by x, kilometers per hour. And we have 660 kilometers divided by x is 300 kilometers per hour. That is the value of x. So when you work out these, you'll get the answer in number of hours, and these will give 2 hours. Let me get, this is a 660 divided by 300, 2.2, 2 and 1 over 5, 2 and 1 over 5 hours, or 2 hours. You're supposed to give this one, you can give it as hours and minutes. So still can give 2 hours, and 1 over 5 will be 12 minutes. Question 21. On the Cartesian plane below, triangle ABC has vertices A, then B and C. The coordinates are given there for A, B, and C. While triangle A3, B3, C3 has vertices. So the vertices are given A3, B3, and C3. The line joining A2, B2 is part of a triangle A2, B2, C2. So you can see the figures are there. A3, B3, C3. Then triangle ABC is there. B2, A2 is given there. Let's go to the questions. Part A. Triangle A1, B1, C1 is the image of triangle ABC under an enlargement center 2.5, negative 0.5, and scale factor negative 2. On the same grid, draw triangle A1, B1, C1. So look at the figure here. So triangle ABC, this one, you're supposed to enlarge this one with the center 2.5, 0.5, with the scale factor being negative 2. So let us identify the center of enlargement first. 2.5, 0.5. 2.5, 0.5 is there. So let me identify the center. So it will be here. So the center is there. So here is the center, 2.5, negative 0.5. And this is negative or enlargement with negative scale factor. It is an enlargement with the negative scale factor. And therefore, in negative enlargement, the object and the image will be on the opposite side of the center of enlargement. So if the center of enlargement is here and the object is here, so the image will be on the opposite side. So the center of enlargement is there, then the object and the image are on the opposite side. So this is what you're going to do. We'll take each point at a time. So we take point A and we join it to the center of enlargement using a straight line. So using a straight line, we do that. So here we have the center. Let me mark it. So the center of enlargement is here. So is here. So we join that using a straight line. Use a ruler to do this. I'm sorry. So join it like that using a straight line. And then now we want to get now where A1 will be. So you can see we have A is there, the center is there. Since you're enlarging this one by -2, we will take that distance A to the center. Let me indicate the center here. So that is the center, A to the center. And then we take twice that distance. So this distance, AC, we take that distance, then twice that distance, we count from C, and then we shall have A1. So you can take this distance, A to the center, using a pair of compass, or you can simply count the squares. I'll count the squares that are in between from A to C. So from here, so we have 1, 2, 3. There are 3 squares, that is 3 centimeters. So twice that distance, I'll count from C, 6. So from here you have 1, we have, kindly check how I'm counting. So from C here, I have 1 square, 2, 3, 4, 5, and 6. So this is where we shall have A1. So A1 will be here. That will be A1. Do the same for B. So join B to the center using a straight line. B to the center. So B to the center using a straight line like that, using a ruler. And then take that distance from B to the center. That distance, you can take it using a pair of compass or count the squares. So how many squares are here? 1, 2. So from B here, we are counting 1 square, 2 squares. So twice that distance, there will be 4 squares. So 1, 2, 3, 4. So this is where we shall have B1. So B1 will be, here. So 1, 2, 3, 4. So B1 will be here. Then for C, do the same for C. So join C using a ruler and a straight line. So C to the center of enlargement, like that. And then take the distance C to the center. How many squares are these? 1, 2, 3, 4. And see that distance from C to the center of enlargement. So from here to here, this is 1, 2, 3, 4. So now from C, twice that distance will be 8. And it's 8 squares. So 1, 2, 3, 4, 5, 6, 7, 8. So see, so C1 will be here. C1 will be there. So this is where we shall have C1. C1 will be here. And now you can join to have the image of ABC. You can join now. So we have A to B1, then from B1 to C1, then from C1 to A1, like that. So there we have the image under enlargement, the image of ABC, under enlargement -2, that is scale factor, that is a scale factor, and the center 2.5, -0.5. Let's go to the other part. Part B, triangle A2B2C2 is the image of triangle ABC under rotation center, origin, that is 0, 0. 1, state the angle of rotation. Then 2, complete triangle A2B2C2. So A2B2C2 is the image of ABC under rotation with the center 0, 0. So you're supposed to state the angle of rotation. That is the first question. So let's look at these. So you can see it is not yet complete. So we have B2, A2. So C2 is missing. So C2 is missing. That is what we need to actually get. Now, to do that, to get the angle of rotation, because you have the center of rotation, and you're given that A2, B2, C2 is the image of ABC of this triangle and our rotation. So we're going to join. So that means that A2 is the image of A, and then B2, the image of B. So we just need to get the angle of rotation, just need to join the corresponding point and the image. So A corresponds to A2. So we join A to the center using a straight line. We join A to the center of rotation using a straight line like that. And then also you join A2 again to the center using a straight line. So you join, that is the corresponding points and the image. So A corresponds, A2 is the image of A. So you join A to the center of rotation and also A2 to the center. Now the angle that you're going to measure now, you measure the angle from the object to the image, from the object point to the image through the center. That is how we measure the angle. And therefore, the angle we need to measure from the object point is from A to A2. And you can see this is the angle. So the angle that we need to get is actually this angle that is here. So this is the angle that we need to get. And you can see that angle is in a clockwise direction. So if it is in a clockwise direction, that angle will be negative. It will be negative. So this is the angle. We're going to measure this angle through the center. So what do you need to do that? You need a pair of compass but a protractor. You need a protractor to do that. So you need a protractor to do that. So get a protractor, and then this is how you're going to position. So show that the central part of the protractor is at the origin. So like that. So that is how you place it. And I'm going to enlarge it so that you can see it like that. So the angle we need, as you can see, this is the angle that we need to get. So this is the angle, and that angle, let me read. So I can try to extend this line here so that I can be able to get that angle clearly. So let me try to extend that line so that I can get, so you can see I've extended that line so that I can be able to read. And as you can see, that seems to be, that is 141, 43. That is 143. So you can read here. So 143, that is the angle. So from here, you're measuring the angle from, this is 0, this is a 10, 20, 30, 40, all the way, this is 140, then this angle here is 143. So this is the angle that you're measuring here. So that is 143. 143. That is actually the angle 143. So since that angle, we're measuring that one in a clockwise direction. Remember, for rotation in a clockwise direction, that will be negative. That will be negative. So the solution here is negative 143 degrees. Then complete it. So complete triangle A2, B2, C2. Now to complete that, we will require to have only C. We have A2, B2. So what we don't have is C. What we don't have is C2. So for point C, this is how we're going to get it for C2. We're going to join C to the center. C to the center. You can see it is still on the same line with A. So join C to the center of rotation using a straight line. And then you measure 143. 143. So using already we have measured that angle. So you don't need to repeat. So you don't need to repeat that. Already we measured that angle. It is still the same. So 143. So this is how you place it. So you make sure you place it so that it lies exactly. Yeah, you can see there it is. There it is. So you can see this angle. So after joining C to the center, then you measure 143. Then you draw a straight line. Do you see the same line that we drew? You extend it. C will lie on that line there. So after you've done that, the next thing you're going to do is to take the distance. Take this distance C to the center, that distance C to the center, and then transfer the same distance using a pair of compass, or you count the squares. So from C to the center there, how many squares are these? You have 1, 2, 3, 4, 5, 6. So on this line again, you count 6 squares. 1 from original, 1, 2, 3, 4, 5, 6. So it is here, supposed to be here. So C2 is supposed to be here. So this is where C2 is supposed to be located. So it's supposed to be located there. So it's simply taken this distance C to O, that distance CO, you transfer it using a pair of compass, or you count the squares. It is still the same distance. So counted 6 squares from C to O. Then from O, you count 6 squares, you'll get C2 here. So once you've done that, you can now complete that. You can complete these. So B2 to C2. And there we have the triangle A2, B2, C2 is there. We go to the other question. So we've completed that. Now part C. Triangle A3, B3, C3 is the image of triangle A2, B2, C2 under a reflection. 1. Draw the mirror line. Draw the mirror line. So A3, B3. A3, B3. So which is here? This is a triangle. It is the image of this under a reflection. So the question is, we are supposed to identify or draw the mirror line. The mirror line is supposed to be exactly between these two, the object and the image. What we shall do here is simply joining any two corresponding points. I will join, you can join C3 to C2 or A3 to A2 or B3. Either will give. So I'll choose to join B3 to B2, B3 to B2. So B3 is the image of B2. So you join that. And then, because the mirror line is supposed to be exactly between that distance. Remember the properties of reflection. The object and the image are supposed to be equidistant from the line of reflection. So if these are reflection, then we are going to have the perpendicular bisector. The perpendicular bisector of B3, B2 will give us the mirror line. So therefore, after getting that, after joining B2 to B3, or you can join C2 to C3, you construct a bisector of B3, B2, and you simply use a compass to do that. Use a compass to do that. So you know how to construct these. So standing at at B, B3, standing at B3, using any suitable radius, that is half, you extend it more than half that distance. Standing at B3, open your pair of compass such that it is more than half of B3, B2, and then you draw knock up there, and then another one here, another one there. Then with the same radius without changing it, you stand at B2, then you cut that arc, and then you cut the other arc there. So that is how you construct perpendicular bisector of B3, B2. Then join these points using a straight line, the point of intersection of these arcs, using a straight line like that, like that. So there is the perpendicular bisector. So the perpendicular bisector. So this one would be the mirror line. And you can see this one being the mirror line, the object point and the image point are equidistant from these mirror lines. So look at A3, A2, look at B3, B2, look at C3, C2. They are all equidistant from the mirror line. So now that is the mirror line. That is the mirror line. The other question is determine the equation of that mirror line in the form y is equals to mx plus c. The equation of the mirror line. So to get the equation of the mirror line, you just need to get 2 points. And I can see there are clear points here. I can get 2 points here. We have, this point is -3, -1, -3, -1, and then there is 0, 0. There is 0, 0 here. -3, -1. -3, -1. So -3, -1. And then another point on that line is 0, 0, 0, 0 is here. So now with those 2 points, you get the equation. You get the equation. You know how to get the equation of a line? You start by getting the gradient. The gradient will be change in y, which is 0, subtract -1. And change in x, 0, subtract -3. And this will give a third. So that is the gradient. Now after getting the gradient, you simply just use any of these points. So you can use I can use -3 and -1 and any other general point on that line. You can introduce a general point xy. So use these two to get the gradient. Gradient will be y plus 1 divided by x plus 3. And that one should give a third, like that. So let me continue with the working here. So cross multiply here, you have 3y plus 3 is equals to x plus 3. So 3y is equals to x, like that. And then y is equals to a third x. So that is the equation. Just identify 2 points, then get the gradient and get the equation. So y is equals to 3x. Part D of the question, describe fully the transformation that maps triangle ABC onto triangle A3B3C3. So let's go to the diagram. Describe the transformation that maps this triangle to this. So ABC is here and A3B3C3 is here. So that one is very clear to note that these are reflection. And how do you note that? By just taking one object point and the image point. For example, look at A and its image A3. When you look at them, they are directly opposite each other, and that is a property of reflection. And then when you look at them, there's a line that is at the middle there, and that is the one that acts as the mirror line. And these 2 points, A and A3, are both equidistant from that line, which is the mirror line. So look at the squares from A to the y-axis, that is 2 squares. From the y-axis to the A3, that is 2 squares. So this is a reflection. C3, C the same. So this is a reflection, and the line of reflection is the y-axis. So that is a reflection. It is a reflection along the y-axis, or the line x is equals to 0. And that is how you're supposed to solve that question. Question 22. The masses in kilograms of 30 people who attended a health clinic were recorded as follows. So you have the data there. Part A. Complete the frequency distribution table below. 2 marks. So you have the mass in kg, the classes are there, and you're supposed to give the frequency. Now to give the frequency, this is quite easy, because what you need to do, I'll demonstrate using the first 2024. You get the number of people who weigh between 20 to 24 kg. So from this table here, any value that is between 20 to 24, just mark it. So this is how we do it. 20 to 24, that is 1, 2, 3, 4, and then do you have another one? 5. Yeah, 5. So all the values between 20 to 24, you confirm, and for this one you need to be very keen. 1, 2, 3, 4, 5. So you write the frequency, that is the number of people who weigh between 20 to 24, they are 5. As simple as that. So that is what you do for the rest. 25 to 29, 25 to 29, you count all the values that are between 25 to 29, you count them. 30 to 34, the same. 35 to 44, the same. So once you do that, I've already done this one, so I'm going to fill. I've just demonstrated how you do that from the first class. So for 25 to 29, you'll get 7 people. For the other class, 30 to 34, you'll get 9 people. 35 to 44, you'll get 6 people. 45 to 49, you'll get 3 people. That is how you fill it. Then the other question is on the grid below, draw a histogram to represent the data. Draw a histogram. To draw the histogram, already you can see from the scale, you have been given the frequency density on the y-axis. So on the y-axis, you have the frequency density. Then we draw the y-axis. So that is the y-axis, and the x-axis is there. So that is the y-axis, and you have the x-axis. So you have the frequency density. You need to get the frequency density. How do you get the frequency density? So frequency density is given by the frequency divided by the class width. Frequency density is given by the frequency divided by the class width. So what is the class width here? So how do you get the class width? For example, 20 to 24, you get the boundary, the difference of the boundary. So the upper boundary, that is a 24.5, subtract 19.5. That is the class width. That is how you get the class width. So the class width. So I think I'll have to add that column. Let me add that column here. I have to add it there, that you can use that as well. So now, I'll add the column here for the class width, so that now we have the frequency class width 20 to 24. That is to get the class width, you take 24.5, subtract 19.5, that one you get 5. Then the other one, 29.5, subtract 24.5, again that one gives 5. 34.5 subtract 29.5, the class width is 5. 44.5 subtract 34.5, that class size is 10. Then 45, that is 59.5. 59.5 subtract 44.5, that one gives 15. That gives 15. So now, having done that, now we can go to the frequency density. So the frequency density is given by frequency divided by the class width. So 5 divided by 5, that is 1. 7 divided by 5, that gives 1.4. 9 divided by 5, 9 divided by 5, that will give 1.8. 6 divided by 10, that will give 0.6. Then 3 divided by 15, that is 1/5, which is 0.2. So that is how we get the frequency density. So now, for us to draw the histogram, we need the frequency density against the class width. We have the boundaries. We're going to use the boundaries against the class boundaries. So the lowest is 20. So we can start a little bit lower, 19.5. So start with 19.5 here. So the first one here, 19.5, then 24.5, 29.5, 34.5, 39.5, 44.5, 49.5, 54.5, and then lastly 59.5. So we now go to the first one. The first one is the first class is having frequency density of 1. Frequency density of 1. So we can complete this scale. Already we have the scale here. So 0.2, 0.4. This will be 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, like that. So 1. So we have 19.5 and goes up to 1. To that point, goes up to 1. So here we have that is the class. Then the other one begins from 25. The next one is 1.4. The next class, 25 to 29. Frequency density is 1.4. So 1.4, 1.4. So this is where it starts from here. So 1.4 is up to that point. Then like that. It's okay. That one is okay. So you shade that. So that one is okay. The next class, 1.8. That is from 30 to 34. 1.8. 1.8. 1.8. So we have, so up to that point. So there we have. So that class begins from 30 to 30.4 is okay. So we shade the bars as well. Shade the bars. So there we have. So there we have the class. Then the next one is 35 to 44, 0.6, 0.6. That class goes up to 44.5. It goes up to 44.5, 0.6, 0.6. So 0.6, so which is from 0.6 is here. It goes up to 44.5. It goes up to that point. So It starts from 34.5 to 44.5. So you shade that like that. Then the next one is the last one, 45 to 59. 45 to 59. That is a 0.2. That is 0.2. So 0.2 is here up to the last one there. So we shade that. So there we have it. So we have the histogram is there. The histogram is there. So everything is intact. So we are through. We have drawn the histogram. The y-axis, you can see the x-axis and so on. So it's okay. Now use the histogram to determine, one, the median mass of the 30 people. The median mass of the 30 people. So the median mass. Total frequency, all the people here are 30. They are 30. So the median will be located, the position of the median will be located, you get 30 divided by 2. It will be located at the 15th person. At the 15th person. So I will need to introduce another column here for explanation. How we go about this of the cumulative frequency. Cumulative frequency, the first frequency is 5. 5 plus 7 is 12. 12 plus 9 is 21. 21 plus 6, 27. 27 plus 3 is 30. Total frequency. So the median will be located at the 15th person. Where is that class? We identify that class. So the 15th person will be located at 30 to 34. 30 to 34. When you look at whatever we have here, we have 5 and then we have 12. So you can see here up to this point you have 12. So the median will be located at this particular class that is here, where we have 21. This is where we have the 15th person will be located in this class. So therefore, this is what we need to do. Up to this point, we have the total frequency will be 5 plus 7. I want you to look at this, 5 plus 7. And then for this class, we don't know the class width, and that is what we want to get. And from the formula here, I'd like you to look at the frequency density is equals to frequency over the class width. So how do we get the frequency? Frequency is obtained by taking the frequency density multiplied by the class width. So to get the frequency, we take the class width multiplied by the frequency density. So the median, since it will be located at 30 to 34, so we will have 5 plus 7, 5 plus 7, 5 plus 7, this is 5 plus 7, or simply 12, 5 plus 7, so 5 plus 7, then plus, now to make 15, because we want to have 15th person, we don't know. What we don't have is the frequency there. And we have the frequency density. So for this one, we don't have the class width here that you're going to multiply in order to have that frequency. So the frequency that we'll have here, so the frequency that you're going to have here, that will give us 15. That is what we want to get. So 5 plus 7, then plus, in order to get that frequency, we need to get frequency density of that class. The frequency density of that class is, and you're using this formula to get that frequency density, which is 1.8 multiplied by the class width. We don't have that class width. That is what we want to get, the class width. We don't have that. So we can let the class width to be a value like x. We let it to be x. And this now will give us frequency that when we add with 5 and 7, we'll be able to get 15. So this one should give 15 like that. So this will give 12 plus 1.8x is equals to 15. So 1.8x is equals to 3. That is 15 subtract 12. And then x, therefore, here will give. So x will give 3 divided by 1.8. And this will give 1.6667. So this is the class width that we need, because the class is here. So from this particular point here, from 29, this is the lowest boundary of that class where we shall have the median. So from 29.5 the class width that we need to add in order to go up to where we have the median, where you're going to draw that line, is 1.6667. So now the median will be given by, so median will be given by, we take 29.5 plus 1.6667, because we said the median will be located here. So what we don't have there is the class width, and we have already obtained the class width that we are going to add from that class, that is from here. We add a certain width, which is 1.6667. So when you add these, you'll get 31.1667. That will be the median. Sometimes you require to draw the line where the median lies. You'll just simply come here and draw the line. So we have this scale here. Forgot to break this scale. You have to break this scale here. It is not uniform at that point. So one small square here. This is 1. So these are 20. This is a 5. So one small square represents 1. So 31.1. 31.1. So this is 30.1. 30.5 will be here when you add 1. 30.5, then 31.5. So it will be located somewhere here, because this is a 30.5. Then the next one will be, the next square there will be 31.5. We are not yet at 1.5, it is at 1.2. So it will be located somewhere here. So let me draw that line, and draw that line where it will be located somewhere there, somewhere there, somewhere there. That line is not visible. Can use another one. So the median will be located there. So in case you're required to draw that line, you can draw it like that to show where the median lies. So here is the line. This is where we have 31.2. This is 30.5 is around there. So that is where that 1.2 is likely to be located, somewhere there. So in case you're required to draw that line, that is what you do. So this is the median. So that is all about that part. The number of people, part 2 of the question, the number of people who had a mass of 41.5 kg or more in this question now. So the workings that you find here, these workings are for part 1. So this question, the number of people who had a mass of 41.5 or more, 41.5 or more. So which class is that has a 41.5? So 41.5. So 41.5 is here in this class. 41.5 is here, as you can see, is in that class. So we need to get the class width first. So from 41.5 to 44, the maximum of this class, the class size is a 44.5. So 41.5 is here. So let us get first the number of people that are here between 41.5 to 44.5. So this is how we do it. We take 44.5. So we take 44.5 and then we subtract 41.5 like that. So that will give the number of people. We want to get the number of people that are above 41.5, or in these from 41.5 to 44.5. And you know how we do this? So whatever we have is the class width. So we have obtained the class width. So the class width is 44.5 subtract 41.5. Is what you've done. And this will give 3. This will give 3. That is the class width. And remember how we are getting frequency. Frequency, the number of people. We are using this formula here. Frequency. We take the frequency density of that class, multiply by the class width. So the class width is 3. So the frequency density of that class, is here. The frequency density of that class is 0.6. So you have to multiply that by 0.6. So to get the frequency, you get 3 multiplied by the frequency density, like that. This will give the number of people that are above 41.5. So between 41.5 to 44.5. And here you get 1.8. I'll tell you what to do because you can't have this fraction, this is a decimal, you're representing people. So after you've done that, that is for that particular class. So for that class, there will be 1.8 people. It sounds funny to say 1.8 people. So this is the number of people we've got there. Then, since we want 41.5 and above, from 45 to 59, there are 3. 45 to 59, there are 3. So you add 3. You add 3. You add 3. And when you add 3, you get 4.8. Because you're going to round this one downwards, not 4.8 people. This will be 4 people. It will be 4 people. That is how you're supposed to solve that question. Question 23. In this question, use a ruler and a pair of compasses only. Line AB is a diagonal of a quadrilateral ACBD. AB is equals to 6 centimeters. So the line is there. So it's supposed to complete by first. Let us first make sure that AB is 6. So the run is not complete. So take a measurement of 6. So 6 centimeters. So that is 6. My pair of compass is calibrated. That is 6 centimeters. So now we have B. Now have the location of B. So B is here. Then question part A. Locate vertex C of the quadrilateral ACBD such that angle BAC is equals to 45 degrees and angle ABC is equals to 60. Complete triangle ABC and hence measure the length of AC. So angle BAC, so that means at A we shall construct 45 degrees. So BAC, so that is the angle at A. So at A we construct 45. How do you construct 45? We shall construct 90 degrees and then bisect it. So we start by constructing 90 degrees at A. So this is how we do it. 90 degrees. So we stand at A. In the suitable radius, mark an arc there. And then with the same radius, mark another arc there. Then from there you can adjust and stand on this arc that you made here. In a suitable radius of your choice, again, mark an arc there and mark another one down here. Mark another one down there. So with the same radius without changing it, stand on this point, then cut that arc and then cut the other arc there. So that is 90 degrees. When you join these with a straight line, when you join these on using a straight line like that, that will be 90 degrees. So that is 90 degrees. And you're supposed to join that one from that point all the way down there, point of intersection of those arcs. So that will give 90. So let me rectify something here. So from this point down there using a straight line, that is 90. So after getting 90, we bisect that angle of 90 that we have constructed. So how do we bisect that? We stand at A. Stand at point A. So standing at point A, using any suitable radius, you mark an arc there, and then you mark another arc there. Then from there, you stand on this arc that you made here, and mark an arc there, and then stand on this arc that you made here, and cut that arc. So now you have that 45 by joining point A. Join point A to the point of intersection of those arcs of 45 degrees. So let me make this one longer. So you join that using a straight line. You shall have 45 degrees. So that is 45 degrees now. You've bisected. So this is 45 degrees. Now we need to construct 60. Now angle ABC is equals to 60. We are still on part A. So we construct 60 degrees at B. So to construct 60 degrees at B, this is what you do. You stand at B and you want to construct 60 degrees to the left hand side of B. So stand at B in a suitable radius of your choice, and within a suitable radius, you mark an arc here. You mark an arc like that, bigger arc, and then with the same radius without changing that radius. Don't change the radius. You come and stand at this point where you made that arc, and then you cut that arc. Like that. So now after doing that, you join this point B, the point of intersection of those arcs. That one should be 120 degrees, 120. On the left, on the right hand side, it will be 120. On the left hand side, you shall have supposed to be, so there we have. So now that is 60 degrees. So this is 60 degrees. So now we have identified point C, because point C will now be this point of intersection here. This will be the point. This point will be C. We've constructed 90 degrees here, then 45, then 60. This point of intersection becomes point C. So that is point C. So for part A is done. Triangle ABC is complete. Now we go to part B. Diagonal CD, which is 10 centimeters, intersects with diagonal AB at right angle. Complete the quadrilateral. So we have a diagonal that runs from C to D, and it intersects with diagonal AB at right angle. So that means it is moving, that diagonal originates from C, and then it meets this line at right angle, or 90 degrees. So that is simply a perpendicular dropped from C to line AB. That is what we need to do. So we simply drop a perpendicular from point C to D. So this is how we drop a perpendicular. You stand at C using your pair of compass. You stand at C, and then make sure you open your pair of compass wide enough. Mark two arcs on line AB extended. So line AB extended like that. Then from there, you stand at this point, and then you mark an arc there. And then with the same radius, without changing that, stand on the other point, and then cut that arc. You cut that arc like that. Then join C, point C, the point of intersection. Point of intersection is there, like that. So that is the perpendicular. So we have dropped perpendicular from C, the point of intersection of these arcs. So we stood here, then made an arc here, another one here. Then standing at this point, we made this arc. Standing at this point, we made this arc. Then we joined. So that line is perpendicular to AB. So CD is 10 centimeters. So now we should have 10 centimeters along that line. So from C, you can use a ruler. So from C, that line that you've drawn. So from C, now you should have 10 centimeters. 10 centimeters. Can use a ruler for these. So 10 centimeters is that point. So that is 10 centimeters. So with 10 centimeters, you can take this measurement using a pair of compass from a ruler. So my pair of compass is calibrated. That is why you can see I've taken that from the pair of compass. So now D will be here. So that is why we shall have D. Now you're supposed to complete the quadrilateral. So by simply joining A to D, then from D to B, like that. And there we have the quadrilateral. So A, B, C, D is there. So the other question is calculate the area of the quadrilateral. So the area of the quadrilateral. So when you look at this quadrilateral, it is made up of two right-angled triangles. So if I can denote this point here as M, so you have triangle ADC and triangle DCB. So it is made up of two triangles. So we shall get the areas of the two triangles and we add. So let us start with the area. So we'll do it here. So area of ADC, that is triangle ADC. This triangle area is equals to half base height. So what we need to get is we have the base will be CD. So half times the base will be CD. This will be the base, which is 10, times the height. The height will be AM. So we need to get that measurement. So let me take that measurement. That is, that one is 3.5678. That one is 3.8. So this one is 3.8. And if that one is 3.8 and AB is 6, then the other one will be, for this one will be 2.2. So that you have 3.8, 2.2, that will be 6. So that is how you're supposed to do it. So a half times base times the height is 3.8. So that will give by 2 and by 2, 5. So we multiply that. So 5 times 3.8, that will give 19. That will give 19 centimeters squared. Then now we get the area of CDB, that triangle. So again, it will be a half times the base. Base is the same, CD, which is 10, times the height. The height now will change. The height will be this. This is the perpendicular height, which is 2.2. So by 2 and by 2, 5. So this is 22, 2.2 times 5. You get 11 centimeters squared. So total area will be 19 centimeters squared plus 11 centimeters squared, and this will give 30 centimeters squared. That is how you're supposed to solve that question. Question 24. The displacement x meters of a particle moving along straight line after t seconds is given by x is equals to 2t cubed, subtract 9 over 2t squared, subtract 15t plus 3. Determine A, the velocity of the particle when t is equals to 3 seconds. The velocity. So you're given the displacement and you're required to get the velocity. How do you get velocity given displacement? You simply differentiate displacement to get velocity. So we'll simply take this expression given here for displacement. We differentiate that with respect to t. So dx dt, that is what is going to give the velocity. And when you differentiate these 2t cubed, you get 6t squared. Differentiate 9 over 2t squared, that will give 9t. Differentiate negative 15t, you get negative 15. So that is what you get. Now when t is equals to 3, you simply substitute. So velocity will be 6. Substitute t with 3. So this will be 3t squared. That is 3 squared, subtract 9. Then t3, subtract 15. And this will give 6 multiplied by 9. That will give 54. 54, subtract 27, subtract 15. And this one gives 12 meters per second as the solution. Part B, the value of t when the particle is momentarily at rest. The value of t when the particle is momentarily at rest. So one thing that you're supposed to know, that when the particle is momentarily at rest, velocity at that point is 0. So we simply take the velocity. We have velocity. We got velocity as 6t squared. We got velocity as 6t squared, subtract 9t, subtract 15. From the previous part, we have that. Is there the expression for velocity? So this one, when the particle is at rest, is supposed to be equated to 0. So you can see that is a quadratic equation, and when you solve it, we'll get the time when the particle is momentarily at rest. We're going to have two values of t. So we can simplify this by dividing all through by 3, and this will give 2t squared minus 3t minus 5 is equals to 0. So let me use factorization. Look for two numbers whose product is negative 10 and the sum is negative 3. Those two numbers are negative 5 and 2. So now you shall have 2t squared plus 2t minus 5t minus 5 is equals to 0. Factor out, 2t is common. You have 2t plus 1, then minus 5t plus 1 is equals to 0. This will give 2t minus 5 multiplied by t plus 1 is equals to 0. So this is how you get the two values of t. First one is 2t minus 5 is equals to 0. So this one will give t as 5 over 2 or 2.5 seconds, or t plus 1 is equals to 0. Here t will give negative 1 second. So you're going to ignore this negative time, and therefore we shall have t as 2.5 seconds. Part C, the displacement when the particle is momentarily at rest. The displacement. Now we already have the time when the particle is momentarily at rest. The time is 2.5 seconds. Now we are supposed to use this time when the particle is momentarily at rest to get the displacement. So we use the expression for displacement. We have it up there, which is 2t cubed minus 9 over 2t squared minus 15t plus 3. So we simply need to substitute t with 2.5 seconds to get the displacement. So you have 2, t is 2.5 cubed, subtract 9 over 2, then 2.5 squared minus 15, 2.5 plus 3. So that is what you're supposed to do. So when you work out these using a calculator, for this one you get 31.25. Then 9 over 2 times 2.5 squared, that will give 28.125. And then 15 times 2.5, you get 37.5, and then plus 3, like that. And this gives, when you work out these using a calculator, you get negative 31.375 meters. So that is the displacement. Part D, the acceleration of the particle when t is equals to 2 seconds. Acceleration. We don't have the expression for acceleration, but how do we get that? We get acceleration after differentiating velocity. So we have velocity. Velocity is there. We got it in the second part as 6t squared minus 9t minus 15. So now when we differentiate velocity with respect to t, this will give acceleration. 6t squared, differentiate that with respect to t, you get 12t, negative 9t, this will give negative 9. So that is the expression for acceleration. So acceleration is given by that. So now at t is equals to 2, we simply need to substitute. So acceleration is equals to 12, t is 2, then subtract 9. So this will give 24, subtract 9, and this will give 15 meters per second squared. So that is how you're supposed to solve that question.